Now let's take a look at the concepts of graphing logarithmic functions. So graphing logarithmic log functions, if you will. Alright, so recall last time that log functions are basically inverses of exponential functions, right? So let's look at this, the basic format for the standard log function. So the standard log function. And that's basically going to be written as f of x equal to log base b of x, for example, right? Some base b. All right. Now, first of all, before we talk about graphing this, let's talk about the range and domain, right? Let's recall if for the exponential function, it was f of x equal to what? Basically b to the x power, if you will, right? So let's go ahead. So, and these are inverses of each other. And let's recall for the domain earlier of the exponential function, domain was what we can plug in for x. Well, that's going to be all real numbers. All real numbers. All right. If you're writing that in interval notation, it will be negative infinity to infinity. All right. The range, though, was all positive numbers, because no matter no matter how negative x is, if you take the base to the negative number, it'll still be a positive number. So let's recall that. So therefore, the range is going to be all positive numbers. All positive numbers. Positive numbers. And the way we wrote that was set of all y values, range for y for range, such that y is greater than what? 0, right? Strictly not even equal to 0, strictly greater than 0. All right. So let's recall these facts here. Right. Now again, if you're writing that interval notation, it'll be parentheses 0 to infinity, obviously. All right. So that will be the range. Okay. So either way is fine. All right. But anyhow, all positive numbers for range, all real numbers for the domain for the exponential function. Now, since the log function is the inverse of this function, then the range and domain will switch around. All right. So the domain, if you will, of the logarithmic functions will be the range of the exponential function. The range was what? All positive numbers. So domain here for x is my domain now, will be all positive numbers. So it'll be all real numbers x, such that x is greater than 0. Okay, so again, this range becomes the domain for the log function, because they are inverses of each other. All right, and the range, as you may suspect, will be what? All real numbers, because that takes on the domain of the exponential. All right, so basically all real numbers here is what we're getting at. All right, for the range of the log function. All right, so keep this in mind. Basically, you cannot take log of 0 or even log of 0 or a negative number. So again, so this number inside that we're taking a log of, either by calculator or by hand, has to be a positive number. All right. So let's go ahead and take a look at the basic log function. Let's go and start by graphing these log functions. All right. Let's go ahead and do that. Let me go ahead and clear out the screen. Let's suppose I want you to graph, for example, f of x equal to log base 2 of x. Real basic graph here, log base 2 of x. All right. Now, it's kind of, and obviously we're going to make a table here, right, to graph this x and f of x, if you will, right. We plug in the x to get the function value. But this is more challenging for us because we're taking the log of that number. If we don't pick x carefully, it could turn out to be a decimal, very likely. All right. So, and we want to stay away from that when we're making a table. We want nice integers, if you will. All right. So let's go ahead and think about how we can generate this table. Well, a better way to generate this table is to write it in terms of an exponential. In other words, the function values are my y. This is basically y right here, right? So I can rewrite this as y equal to log base 2x. No big deal. I'm replacing the f of x with y, which is what f of x is, the function values, or the y coordinates, if you will, right? So now let's convert this to an exponential. And how do we do that? Well, remember, we take the base, y is the exponent, right? So this is the exponent, because logs are exponents, keep that in mind, right? All right, so that means we're going to take the base. This is the base right here. All right, that's the base. So we're going to take the 2 to the y power, right? Base to the exponent is equal to whatever's inside the log, equal to x. In other words, we're saying x is equal to 2 to the y. Now, if you look at this, so this equation is the equivalent of this log function, if you will. So, what does that mean? It means that we have x in terms of y. That means it's easier to generate a table, if you will, of x and y, not by picking numbers for x, but by picking numbers for y. So in this case, we're going to pick any y and plug in for x. Plug in for the x coordinate. All right. So in other words, let's pick y to be, for example, 0. Right. What is 2 to the 0 power? That's pretty easy to calculate, right? That's 2 to the 0 power is 1, right? All right. So we can recall that. Let's pick y to be 1. What's 2 to the first power? 2 to the first power is what? 2. Let's pick y to be 2. What's 2 to the second power? So again, I'm picking y, plugging it into this equation to get the x coordinate. All right. So in other words, my first 2 points will be what? 1, 0, and 2, 1 for my function, for my log function. All right. So if y is 2, what's 2 squared? Well, 2 squared is what? 4, obviously. All right. Let's pick one more here, one more positive number. How about 3 for y? And keep in mind, the range is what? All real numbers, right? So therefore, I should be able to pick some negative numbers as well. So not just all positive numbers. We'll do that in a moment. But anyways, if I pick 2 to the third is what? What's 2 cubed? 2 cubed is what? 8, all right? So x is getting pretty big, so I'm not going to pick any more positive values for y here. Let's try some negative numbers. Let's try negative 1, all right? What's 2 to the negative first power? Well, if you plug it in, let me show some work here. Then let me do it on this side since I'm calculating x, right? So what's 2 to the negative 1? Well, isn't that 1/2, all right? Because we convert that to a positive exponent by pushing the 2 down. So 2 to the negative 1, that's a negative 1 right there. Sorry about that. So that should be negative 1 right there. So apologize for the sketchpad error. Sketchpad giving me some trouble here. But yeah, so that's going to be 1/2, bottom line. So y is negative 1, x is 1/2. Let's try negative 2 for y. What's 2 to the negative 2? Well, 2 to the negative 2 is going to be 1 over 2 squared, or what? 1/4, right? So as you can see, my domain will be all positive numbers, right? So again, range and domain got switched around with the exponential function that we did that we wrote down earlier. All right. Anyways, so this is the table that we have here. So let's go and fill this table on this function. All right. Excuse me. So it's going to be what? 4,2. So the point 4,2. We have the point 8,3. When x is 8, the f of 8 is going to be 3, right? 1/2 for x, negative 1 for y, and 1/4 for x, and negative 2 for the y value. But anyways, let's plot these points and see what the sketch of the graph looks like here. Let me make a nice big, try to do as best I can on the sketch pad here. So it's hard to draw straight lines on this thing, but we'll do the best we can. Here's y. Oops, go out of here. There's x. All right. So see, I need to go out to 8 here. So 1, 2, 3, 4, 5, 6, 7, 8. All right. And then go up to 3, 1, 2, and 3. Go down to negative 2, 1, and 2. All right. All right. Anyways, let's go and plot these points. 1, 0. So here's 1, 0. So this is the what? This is the x-intercept for the log function. 2, 1. There's that. 4, 2. 1, 2, 3, 4, and 2 up here. And 8, 3 all the way out here. All right. What about these 2 points? 1/2, negative 1. 1/2, negative 1 is roughly here, and it's got basically the graph's going to tail off along the what? Along the y-axis. All right. We talk more about this type of tailing off in the higher math class, but just know that it tails. In other words, what it tails off means what? First of all, the other part of the graph looks like this. Let me just, oops, kind of missed it a little bit. Kind of. Yeah, sorry for the sketch pad here. But darn it, so I can get it better. Okay, so this is the curve that I was trying to draw. Sorry about that. And tails off along the y-axis. Then it tails off right, oops, towards the y-axis in sort of a vertical format here. All right, but yeah, but this is basically the curve that I'm trying to sketch for f of x. F of x being this log function. Log base 2x. All right. So again, the bottom line that I want you to get from this is what? Convert the log function to an exponential, and then make your table so you can graph it a lot easier that way. All right, let's try another one here. See if we can get the sketch of the graph correctly here. Let's go and try another one. Let me go and clear out the screen. All right, let's go and graph g of x. Let's graph, not gap, but graph, sorry, g of x. Let's say equal to, how about log base 2 of, let's say, x minus 1. All right, let's try that one. Okay, again, let's write it in terms of y. Again, my g function is the y, right, basically. So function values are y values, so let's let y be, so let y be the function, log base 2 of x minus 1. All right, convert that to an exponential. Again, y is the exponent, 2 is the base, so we'll take 2 to the what? Y power equal to whatever's inside the log, x minus 1. All right. Now, for the x minus 1, be a little bit careful here, because if it's just x, then we know the domain is what? All positive numbers, right? But look at the x minus 1. We have to make sure that this thing here is never 0 or a negative number. In other words, for domain, we need to make sure that x minus 1 is greater than 0. Or x is greater than what? If you add 1 to both sides, 1. So we have to make sure that x is bigger than 1. But again, we're not too terribly concerned about that, because we're not picking x here. In this setup, we're picking y actually, right? So let's add 1 to both sides to get x by itself. Solving for x there. So x is equal to what? 2 to the y plus 1. And this plus 1 is not part of that exponent. Keep that in mind. Right? We'll do another one where it is part of the exponent, and you'll see some relationships there in a moment. All right? But let's make a table of x values and y values. Again, we're what? We're picking y, plugging it in to get the x coordinate. So don't pick x first. Pick y first. All right? Let's pick y to be what? 0, for example. What's 2 to the 0? 1. 2 to the 0 is 1, right? Remember that. A number to a 0 power is 1. So 1 plus 1 is going to be what? 2. All right? Let's pick y to be 1, for example. 2 to the first power is what? 2 plus 1, 3. 3 for x. Right? Can we see that? If I pick 1 for y, 2 to the first is 2. 2 plus 1, 3 for x. Okay? Let's pick 2 for, I'll do one more y here. 2 for y. 2 squared is what? 4 plus 1, 5. Right? Now, x is getting bigger, right, as y is increasing, right? So let's go ahead and try a negative number for y. Okay, so let's pick negative 1 for y, right? So negative 1, what's 2 to the negative? Well, earlier we had 2 to the negative 1 being what? Here, let me do some calculation. 2 to the negative 1 was 1/2 earlier. Remember that? We had earlier with the log base 2 function. All right. Then 1/2 plus 1, though, is what? 1/2 plus 1 is what? 1.5, or 3/2 if you want to do it that way, but I'll just put the mixed number in, 1.5. All right? And let's just do one more here, negative 2 for y. That's 1/4, right? Earlier we had 2 to the negative 2 is 1/4. If you saw what I did earlier, right? Review what I did earlier. But anyways, 1/4 plus 1 is going to be 1.25. All right? Bottom line is this, though. This log graph is going to tail off not at the y-axis like the earlier graph we have. Right? Let me go out to 5 here. 1, 2, 3, 4, 5. All right, and let's see here. 1 and 2, 1 and 2. All right. So let's plot. Let's look at the x-intercept 2, 0. So instead of having 1, 0 we had last time, now we have 2, 0. Keep that in mind. All right. 3, 1. All right. 5, 2. All right. And then 1.5, negative 1. So 1.5 is here's 1. Here's 1.5. Right. Negative 1. So the graph is going to, instead of tailing off along the y-axis like the earlier one, it's going to tail off, as you can see, 1.25, 1 1/8, and so on, right? So it's going to tail off along this little, let me make a little dash vertical line right here. This is called a boundary line that's called an asymptote. Which, again, don't worry about the term here. We'll deal with that in a higher level math class. But the graph is going to tail off along this vertical line. So instead of tailing off at the y-axis like we had in the earlier graph, this is going to tail off at what? At this vertical line, x equal to 1. But anyways, here's what the graph looks like. It's the exact same graph as before. Oops, again, I kind of missed the point here. Do the best I can, but a little bit better with the sketch pad here. But tails off right here. Like bottom line, tails off right here. So, anyways, this is the graph of g of x. Now, if you saw earlier with f of x, f of x was like this, right, where 1, 0 was the x-intercept, right, that we had earlier. So basically, we can apply concepts of translation here to this, because remember, the x from the f function is replaced by x minus 1. When x is replaced by x minus 1, if you recall from an earlier concept, that this graph is the same as the log, so let me say same as f of x equal to log base 2x we had earlier, but shifted what? 1 to the right. X replaced with x minus 1, you're shifting this 1 to the right. So shifted 1 to the right. So we can apply concepts of translation to these graphs as well. Let's take a look at another one here and show you some more translation concepts. Let me go and clear out the screen. Let's graph this log function. Let's graph let's let me call h of x instead, if you don't mind. Use h here. Let's say it's a log base 2 of x. Let's make it minus 2. All right, minus 2. So keep in mind, this minus 2 is not part of the log. All right, what's inside the log is just x. So my domain will still be all positive numbers. All right, this minus 2 is not part. If I put parentheses, then it would be, right? But there's no parentheses here. That means what? This is not part of the logarithm, this minus 2. We just have to take the log of the value and then subtract 2 from it at the end. But anyways, let's convert that to an exponential. Let's call my hy again, right? So let's let y be log base 2x minus 2. Again, this minus 2 is not part of the log, so I can simply add it to both sides to isolate the logarithm as I'm solving for x here, right? So this is y plus 2 equal to log base 2x, all right? So therefore, we can now convert this to an exponential, right? Again, this is now the exponent, though, right? This is now the exponent. So it's going to be 2 to the y plus 2. So the plus 2 is now part of the exponent, equal to what? What's inside the log? Just x. Or x is equal to 2 to the y plus 2 to make our xy table. All right? Again, let's pick y and plug it in to get the x coordinate. So let's pick y to be 0, for example. If y is 0, that's 1, right? 2 is, apologize, but this plus 2 is let me show the work, maybe. That's probably better. 2 to the 0 plus 2, this is 2 squared, apologize for that, equal to what? 4 for x. So it should have been 4, so sorry if I confused you on that one. But yeah, this plus 2 is part of that exponent of 2 to the y plus 2. Okay, let's pick y to be 1. What's 2 to the 1 plus 2 is 3, right? So again, you show the work here, 2 to the 1 plus 2, that's 2 cubed. So that's going to be what? 8, 2 cubed. So that's going to be 8. My x is getting pretty big already, so I'm going to try some negative numbers now. Let me try negative 1 for x. All right, negative 1. Plug it in for, not for x, for x again, for y. I apologize again. We're so used to picking x and plug it in, but now we should pick y and plug it in for the x, though. So my apologies again here. Yeah, so it should be 2 to the what? Negative 1 plus 2. 2 there, sorry about that. And that's equal to 2 to the first power, or just 2. So 2 for x, all right? If I plug in negative 1 for y, again, we're picking y, plug it in to get the x. All right, let's just do one more. How about negative 2 for y? Negative 2, so that's going to be what? 2 to the negative 2 plus 2, or 2 to the what? 0, or what? What's 2 to the 0 again? 1. Okay, so 1 for the x. All right? So, let's see here. I'm running out of space, so let me just do one more, if you will, here. I'll do a negative 3. Let me squeeze in a negative 3 down here for y. Okay, I'll do one more calculation here. So hopefully you can see it okay. But 2 to the negative 3 plus 2 is 2 to the negative 1, right? But that's 1/2 we saw earlier. So this will be 1/2. Let me squeeze that in down here on the bottom of the screen. 1/2 down here, sorry about that, for negative 3 for y. All right? But anyways, let's see what the sketch of the graph looks like. Here's y, and here's x. I need to go all the way out to 8 here, so let me be aware of that. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8. All right, that's an 8 right there. All right. So let's see, for the y, just go down to negative 3. That's fine. 3, 1, 2, and 3. All right. So 4, 0. So 1, 2, 3, 4. All right, 4, 0. And let's see here, 8, 1, 8, 1. all right, 2, -1, so 2, -1, all right, and let's see here, 1, -2, so 1, -2 is down here, and 1/2, -3, so 1/2, -3. So the graph is the same. It's going to tail off. Again, it's going to still tail off along the what? Along the y-axis here, as you can see, right? Because 1/2 for x here. You see that? So here's what the sketch looks like. The best I can here. Sorry, I missed it a little bit. All right. So the graph is going to still tail off along the y-axis. So this is h of x. All right. But let's take a look at these the concepts a little bit, perhaps, right? From the earlier table we had. Let me see here. What's the best way to look at this here? Well, what I really want to show you is that this is just a vertical translation of the basic f of x graph we had earlier, because we're minusing 2 from it, right? Notice we can look at this if f of x we had earlier was log base 2x, right? If we that's x right there. If we look at this as then h of x, then it's going to be what? This is f of x right here, so this is f of x minus 2. So this is a vertical translation, shift 2 what? 2 down. So this graph is the same as the log 2x graph we did originally, but we're shifting it 2 down. Okay, so again, we're using concepts of translation. I can also use those concepts to graph aside from this table setup if we know the basic graph of f of x, that is, right? But again, the theme again is going to be what? Converting the log function to an exponential here to make your table, and then you can get the graph by picking y, plugging it in to get the x. Okay, so again, that's really the bottom line once you get it, regardless of the translation concepts or not. All right. But again, so I'll just finish it up by saying same as f of x equal to log base 2x, but shifted 2 down. Shifted 2 down. Vertical translation. All right. So let's go ahead and let's do one more to wrap things up here in terms of graphing these log functions. Let me go and clear off the screen here. Let's go and try this one. Okay, let's look at let's graph g of x equal to, let's say, log. We'll go back to base 2 again. There's other bases you can do, but numbers get really big with other bases, of course, right? Let's try x plus 2 minus 1. X plus 2 minus 1. All right. So again, this minus 1 is outside the log. This plus 2 is inside the part of the domain here with the x. Now this here is going to involve what? Both a horizontal translation and a vertical translation. Right. So this is going to be the same. If we apply translation concepts, same as f of x, same as the basic graph we had earlier, right? Log base 2x. All right. But shifted what? How's this going to be translated? Well, x replaced with x plus 2, that's going to be shifted 2 to the left, if you recall from the previous homework. And this minus 1 down here means what? 1 down. Okay, so you can use these concepts if you want to move this original graph around. But I'm just going to use the y equal to and make the table here outright. So let's let y. So we're going to let y be what? Log base 2 of x plus 2 minus 1. Then again, we'll isolate the log by adding 1 to both sides. This is a little bit more tricky, but the concept will still be the same. So this will be y plus 1 equal to log base 2 of x plus 2. Let's convert that to an exponential then once the log is isolated. Again, this is my exponent. So this will be 2 to the y plus 1 equal to what's inside the log, x plus 2. Now again, before I continue here, what is the domain going to be? Because this is x plus 2 now, not just x, right? With x, it has to be what? X greater than 0. So this here has to be, the domain for this guy has to be x plus 2 greater than 0, is what I'm trying to say. And then you're going to subtract the 2 over to know that the domain for x is going to be what? Greater than -2. All right? So domain will be greater than -2 in terms of the x values we can pick. But again, we're not picking x here, right? We're picking y and plugging it in to get x. So let me finish solving for x. Subtract 2 on both sides to do that. So therefore, x is equal to 2 to the y plus 1 minus 2. and let's look at our table setup. But again, keep in mind the translation we talked about here, right? It should work out either way. Okay, so let's pick y to be 0. So what's it going to be? 2 to the 0 plus 1 is 1. So 0 plus 1 is 1, right? 0 plus 1. 2 to the 1 is 2. 2 minus 2 is what? 0 here. Okay, 0, 0, origin. Again, you want to show the work, it'll be, let me show the work here perhaps. 2 to the 0 plus 1 minus 2. This is 2 to the 1 minus 2, which is equal to 0. If you 2 to the 1 is 2, basically, right? Okay. Let's pick y again. We're picking y now, right? So pick y to be 1. Let's try 1 here. 1 plus 1 is 2. 2 squared is what? 4. 4 minus 2 is going to be what? 2. Let's pick 2 for y. All right. So 2 for y. 2 plus 1 is what? 3. So I'll show the work on this one. How about 2 to the 2 plus 1 minus 2, which is going to be 2 to the third minus 2, or what? 8 minus 2, or what? 6, if you will, right? 2 cubed is 8, right? So 6 is going to be the x value, all right? If you plug in the 2 for y, all right? So x is getting up there now. Excuse me. So let me go ahead and pick y to be a negative. Now how about negative 1 for y? So negative 1 for y, that plus 1, that makes it 0, right? 2 to the 0 is 1. 1 minus 2 is going to be what? Negative 1. Negative 1 right here. All right. Again, you want to show the work. It's going to be 2 to the negative 1 plus 1 minus 2. But that's equal to 2 to the 0 minus 2. 1 minus 2, negative 1. All right. So that's going to be negative 1 for the x here. Let's do one more for y. Negative 2 for y. Okay. And this time I'm just going to do it in my head and verbalize this. What's negative 2 plus 1? That's negative 1. What's 2 to the negative 1? 2 to the negative 1. Maybe show a little work. 2 to the negative 1 is 1/2. Right. But you have to minus 2 from that. Right. So minus 2. That's going to be negative 1.5. All right. So negative 1.5 is what I'm getting at for the x. All right. If you plug it in and work it out carefully. But anyways, I'm running out of space. So I want to fit the graph on here. So let me go and do that here, and show you the translation of 2 to the left, 1 down. But hopefully you can see that from the translation concepts we had earlier. All right. So let's see here. 1, 2, 3, 4, 5, 6. All right. So let's see. 1, 2, 3. 1, 2, and 3. All right, so let's plot these points. 0, 0, origin. All right. Keep in mind, we're shifting this 2 to the left. That means normally we tail off on the what? On the y-axis, the original graph, right? So we're going to tail off along this line, this negative 2 right here. And you can sort of see that. Let me draw this vertical line for us to tail off on. You don't have to draw this on the homework, obviously, but just keep that in mind. This imaginary line is where we're tailing our log graph off of, because we're shifting it from what? From tailing off at the y-axis on the original log function to moving it 2 to the left, so we're tailing off right here. And you can see that from these x values. Negative 1, negative 1.5. Next one's going to be what? Negative 1.25, I believe, and so on, right? Anyways, let's go and look at these points here. 2, 1. So 2, 1. And 6, 2, so 6, 2 all the way up here, and negative 1, negative 1, all right, and negative 1.5, excuse me, negative 1.5, negative 2. So that's going to be right about here, all right. But anyways, yeah, it's going to tail off on that imaginary vertical line I've drawn here. But let me finish it off right here. Excuse me. So yeah, so we're shifting a 2 to the left and 1 down. But again, you have to get the original graph alongside it to compare. But again, don't worry about translation so much. Just know how to convert these log functions into an exponential equation to make your table and get the graph properly. All right, let's go ahead and finish out by giving you some problems here. A couple of problems on Blackboard. Here, let me go ahead and clear off the screen here. All right. Now, for Blackboard, I'm not going to have you post the graphs, but obviously you should know how to do that as well. But I just want you to solve for x. So number one, I just want you to write. Let me say, just write as an exponential equation. Now we're solve for x, exponential equation by solving for x. All right. So again, same thing on both 1 and 2 actually. So number 1, let's give you this function f of x equal to log base 2 of x minus 5 plus 3. Right? Number 2, same as before, except this time g of x is going to be log base 2 of, let's say, 2x minus 1. Alright, so convert these log functions to an exponential equation by solving for x. Solve for x on each of these, and post the solution for x in terms of y. That is, solve for x in terms of y, right? This is basically your y right here, right? And post them into Blackboard here. Okay, so we'll go over in class until next time then.